welcome all the KPA members, invitees, special invitees, students to this webinar today. I also welcome Professor R. Shankar, the speaker for today's webinar. So as you know, we have been conducting webinars since last year on a variety of topics, all the way from quarks to cosmology, with the intention of educating our members, or at least informing our members about various topics in the easiest possible manner. They don't have to go outside their home. So this we have been doing, and we have been successful with the cooperation of so many members from institutes, universities, and colleges. And we hope that this cooperation will continue for many more years. And also, we have been conducting these talks in Kannada also, with the intention of encouraging the usage of Kannada in higher education. As NEP also suggests, and we all of us know the necessity of introducing the local languages in higher education, because that is very essential for the proper communication between teachers and students. We all know how difficult it is for our students to communicate in English. So at least we have to break that barrier, and only then perhaps we'll be really truly independent, self-reliant. Or Atmanirbharta means using our own languages, just as they do in most of the scientifically advanced countries, however small that country might be. Anyway, we are doing a little bit of making our contribution in this effort, towards this effort, and I wish you a cooperation in this matter. Today's speaker, before I request him to talk about this topic, the story of the oceans, I would like to introduce him briefly. Professor Shankar retired in August 2017 as Professor of Marine Geology at Mangalore University after 37 years of service. He did his BSc in Chitradurga and MSc in Applied Geology and PhD from the IIT Bombay. He secured first rank in MSc, for which he was awarded the Institute Medal and the Institute Notional Prize. So Shankar was a Commonwealth Academic Staff Fellow at the University of Edinburgh, Scotland during 1991 to 92. He has been conferred several awards like the National Mineral Award by the Government of India, Sir C.V. Raman Award by the Government of Karnataka, Young Scientist Award by the Karnataka Association for the Advancement of Science, for which he is now the General Secretary. He has visited 26 countries in all continents except Antarctica for research, training, and Earth Science Olympiad activities. Presently, Prof. Shankar is advisor to the International Geoscience Education Organization and coordinator for the International Earth Science Olympiad. He is an advisor for Earth Science at Prayoga Institute for Education and Research, Bangalore, and member curricular area group of National Council for Educational Research and Training, NCRT, New Delhi, and also the very active secretary of the Karnataka Association for the Advancement of Science. In the past, he was a national coordinator for Earth Science Olympiad, a chairperson of the International Earth Science Olympiad, advisory board and examination board, and a member of Syllabus Commission, member of IUGS Commission on Geoscience Education, Training, and Technology Transfer. He was Foreign Secretary and Council member of the Geological Society of India also. He has published over 85 refereed research articles. His research interests include environmental geology, environmental magnetism, paleoclimate, paleooceanography, earth science education, and popularization. After retirement, he has dedicated himself to giving webinars and helping individuals, institutes, and organizations that need his help. We are very fortunate that Professor R. Shankar has agreed to give a talk on this topic of oceans. And as I mentioned earlier, he's very good in Kannada also. You can interact with him Kannada also at the end of the talk. Now over to Professor Shankar for his presentation. Okay, sir. Professor Shankar,
Okay.
can you start?
Yes. Many thanks for your kind words of introduction, Professor Basuraj Kagali. I must say that there are two voices.
Please continue. We're not able to hear.
See, until then, two voices were coming with a. I'll just wait for a moment, please. Okay. I do not know whether other people also have the same issue. I'm hearing my voice once more. Okay. Okay. So thank you so much, Professor Kagali, and also the Karnataka Physics Association for the gracious invitation to give this talk. Well, as we noted earlier, people.
No, you please continue. There is no problem.
No. What's happening is I'm hearing my voice twice. There is some problem.
Oh.
Some problem.
Oh.
Sir, good morning, sir. Sir, I guess you can keep your mobile little far away. It will
okay.
reduce that.
Okay. Switch off the mobile, please. Switch off the mobile.
Little far away, sir, due to induction.
Yeah. Okay. Please. Prof. Shankar, please continue.
Okay, I kept my mobile in another room and came. I hope I'll have some luck now.
You should switch it off. Anyway, problem. Okay, please continue.
I think the same thing is continuing, but it's quite disturbing, to give a talk like this, but I'll try to do my best. So as we noted earlier, earth science is not known to many people. The society doesn't know about it.
ಸರ್ 2 ಸಾರಿ ಕ್ಲಿಕ್ ಮಾಡಿದ್ದೀರೇನೋ ಅದರಿಂದ ಅದು ಬಹುಶಃ ಡಬಲ್ ವಾಯ್ಸ್ ಬರುತ್ತೆ.
Yeah, that can be a possibility. One ನಿಮಿಷ. Yeah, that can be a possibility. Yeah.
Yes, sir.
Okay, please continue now. Okay.
ನಮಗೆ ಸರಿ ಕೇಳಿಸ್ತಾ ಇದೆ.
ನಮಗೆ ಸರಿಯಾಗಿ ಬರ್ತಾ ಇದೆಲ್ಲ. We are hearing very clearly. No confusion here.
Yeah. Okay. I think that was the reason. Yeah. So, in order to bring about awareness about earth sciences, Professor Subbarao and I wrote a booklet many years ago titled The Story of the Oceans. This was principally aimed at common people and high school students. And here is the website. I think the same thing is continuing. No. This is.
No, have you joined with your mobile phone? Maybe you should switch off the mobile phone. Probably double
ಇಲ್ಲ ಅದರಿಂದ ಜಾಯ್ನ್ ಆಗಿಲ್ಲ.
ಜಾಯ್ನ್ ಆಗಿಲ್ವಲ್ಲ. ಸೊ ಏನಾಗ್ತದೆ? I don't understand the problem. ಇಲ್ಲೇನು ಇಲ್ವಲ್ಲ. Everyone is muted. All the people are muted here. ಎಲ್ಲರೂ ಮ್ಯೂಟ್ ಆಗ್ಬಿಟ್ಟಿದ್ದಾರೆ.
2 ಸಾರಿ ಕ್ಲಿಕ್ ಮಾಡಿದ್ದು
Okay. Full screen.
Marbury.
And then, okay. So you can download the booklet from here and share it with children and others. So here are the contents of the booklet, and the same thing here. I won't go through all this. Our Puranas say that, Asuras and Suras churned the oceans, the Samudra Manthan, in order to extract, Amrita, the elixir of life. Even in Kali Yuga, we do this, we churn the oceans for several resources like food, mineral, and energy resources. Just to give you some vital statistics of the oceans, they occupy about 71% of the Earth's surface. The average depth is 3,730 meters. The volume is 1.347 million into million cubic kilometers. That's a humongous figure. And the deepest part is about 11.5 kilometers deep in the Pacific Ocean, the Mariana Trench. And if you invert the Mount Everest and put it into this trench, it won't even go into that. Because Mount Everest is only 8,850 meters. In fact, the statistics are so impressive that our defense minister, Rajnath Singh, said that India-Russia friendship is higher than the highest mountain and deeper than the deepest ocean. Anyway, now I would like to say a few things about how oceans are important to us. They're a huge storehouse of resources like mineral, food, and energy resources. They are the best route to transport goods. Bulk transportation is very cheap and easy. And we use them to discharge waste and effluents, unfortunately. So much so that they are referred to as the blue-lidded global dustbin. Oceans also control our weather and climate. The air that we breathe, how pure it is, depends on all this. We use, the oceans for recreation at beaches, water sports, and oceans have also been channels of adventure and discovery. New lands were discovered through voyages to lands that were unknown earlier. Now, a few words about how the ocean basins formed. There is a theory called the plate tectonics theory that explains how the ocean basins formed. Now, the Earth's crust is made up of a number of plates, as you can see in this diagram. That's one plate, another plate, Indian plate, Eurasian plate, and so on and so forth. Basically, what happens is, when the magma is molten rock material, when it comes up to the surface, seafloor, it spreads on either side and pushes the plates apart. So there is new crust produced here. That's a section. Is also a section. New crust is produced here, so they are called the crucible of creation, where new material is formed. And along these boundaries, plate boundaries, there is abundant earthquakes, volcanic activity all along these plate boundaries. Now let's say how the ocean floor looks like. You must be quite curious. We know only the surface of the ocean, what we can see at the surface. But if you go inside, it looks very much like land. You have soaring mountains, plunging valleys, and rolling plains. That's a quick photograph of how the ocean floor looks like. I won't go into the details. These mid-oceanic ridges that I talked about earlier, these are the mid-oceanic ridges running in the middle of the oceans. They run for about 74,000 kilometers. Yeah. These are the mid-oceanic ridges. And they're characterized by high heat flow and earthquakes, volcanism, and hydrothermal activity. Now, what do we see on the ocean floor? You see volcanic rocks and mountains and ridges. Other places are covered by mud or sediment. The white material that you see here is all mud or sediments. If you go inside, it's very dark because sunlight reaches only in the 200 meters of the upper ocean. Light can penetrate. Beyond that, it's all aphotic or dark zone. And it's quite cold inside. In the deep oceans, the temperature is something like 2 to 4 degrees centigrade. Now, how do scientists study the oceans? We use a well-equipped research vessel like this one. This is the RV research vessel Samudram Ratnakar of the Geological Survey of India. This was acquired about 7 years ago or 8 years ago at a cost of 650 crore rupees. I repeat, 650 crore rupees. Quite expensive. We study the seafloor topography or how the seafloor looks like using an echo sounder. When you clap, the sound goes and hits the wall or something and comes back as an echo. We use the same principle here. We send sound waves from the ocean, they go down, hit the seafloor and come back. So measuring the time taken and knowing the speed of the sound, we can calculate what is the depth. We also use a side scan sonar like this one. Basically, it is stored behind the ship and you get data about the seafloor. A band of seafloor is measured simultaneously. Using such sonars, we can detect if there is a plane that is sunken because of an accident. You can see here with enhancement, you can see the airplane very clearly on the seafloor. Many such features we can study using side scan sonars. Now, what lies beneath the seafloor? We looked at only the surface of the seafloor. What lies beneath is also studied by using seismic waves or sound waves, which are sent out by the ship. And then you have a number of earphones or geophones. We say earphones because we use it in our ears. Right now, I'm using 2 of those in my ears. These are called geophones. They collect the reflected signals. And by processing these signals, we can make out what is the structure of the rocks beneath the seafloor. So that's an example of a seismic reflection profile. You can see how the layers are there and all that, okay? Scientists use an instrument called GRAB in order to collect a seafloor sediment sample. It is sent down, it hits the seafloor, and when it is pulled up, the jaws close. So it's exactly like how we bite on an apple. There are 2 jaws like we have. This also has 2 jaws, and it does a job of collecting the seafloor sediment. We also use a sediment corer like this one in order to collect a long cylindrical sample of sediments. And such samples are useful for studying the past climate and other historical aspects. Now, this instrument here collects a number of water samples at different depths. Each of these cylinders collects 1 water sample at one particular depth. Now, this is useful to determine variations in salinity and temperature at different water depths. And that will help us in doing research on various aspects. We'll see that a little later. Now, what you see here is a submarine or submersible. And we use these submersibles for making direct observations of the seafloor and to collect samples from specific locations on the seafloor. Now, does the ocean water move? Let's see whether it moves or not. Let me say that, oceans are not stagnant. They're not like a bucket of water. They're always in constant motion in different directions and different speeds. As you can see in this diagram, the surface water is moving to the north, and this is moving to the south. This is going down, that's going down. So it's quite a complex scenario here. The moving water are referred to as water currents or simply currents. Now, these are currents. Ocean currents are like rivers in the oceans. You can see here, this surface current goes there and sinks. Blue is all underwater, and so on and so forth. So they carry enormous amounts of water. They carry heat, they redistribute sediments, oxygen, carbon, nitrogen, phosphorus. and other elements that are crucial to marine life. They can transport blocks that weigh as much as 9,000 kilograms. Now, this is like, our blood stream in the human body. It does the same job as the blood does, carrying oxygen and energy to different parts of the body. Now, do the oceans hold any economic potential? Yes, they do. Now, you have mineral, energy, and food resources. And I must mention here that mineral resources are non-renewable. That means you cannot produce these mineral resources in a short period. It takes millions of years to form these mineral deposits. Food resources, you can grow every season, every year. So it's not the case with mineral resources. Now, who owns these mineral resources and who can utilize them? Now, there is this Law of the Sea Treaty, which was signed in 1982, that governs the utilization of all of these resources. According to this treaty, there is no single individual or a country that owns the marine resources. It says that all the resources are a common heritage of mankind. It belongs to everybody. It's a fantastic concept, but how it is going to be translated, we have to wait and see. So basically, this treaty spells out the rules and regulations in order to rationally manage our economic resources and conserve them for future generations. So according to the treaty, there are 3 divisions: territorial sea, exclusive economic zone, international area of the seabed. In this diagram, all this light blue is the international area and the dark blue is the exclusive economic zone. As you can see, all coastal nations have this, islands have this exclusive economic zone. Now let's look at India's EEZ, all that is India's EEZ, around Andaman, Nicobar, Lakshadweep Islands. And what we have is about 2 million square kilometers, which is approximately 60% of India's land area. Now, what are the mineral deposits that are found in the oceans? Now, first is the so-called manganese nodules or polymetallic nodules. These are black potato-like objects that are littered on the sea floor. They grow very slowly at the rate of a few millimeters per million years. They contain copper, nickel, cobalt, rare earth elements, and many other metals, which have aroused interest in marine scientists. It's estimated that several billions of tons of nodules are present on the ocean floor. Now, if you look at it, it's like, drakshi, one drakshi hakirtarla payasdalli. It looks like that on the sea floor. And India has been very active in exploring nodules in the central Indian basin. You must have seen springs, in different places in the Himalayan region, near Bombay, near Mangalore also there is one. We find hot springs on the ocean floor as well, not only on continents, but this is a hot spring from the ocean floor. And the temperature here is, up to 380 degrees centigrade. Now, basically what happens is these hot springs, they bring up dissolved metals as they come up here and there and all that. They bring up dissolved metals, and these metals precipitate as sulfides and oxides in order to form metal sulfide deposits or metal oxide deposits. What you see here is, all this is metal sulfide deposits. Now, these are called vestimentiferal worms found in the vicinity of those deposits, in the vicinity of hot springs, at more than 2,500 meters water depth. I repeat, 2,500 meters water depth. There is no sunlight there. It's only hot water, and photosynthesis is out of the question. Here, life is driven by what we call chemosynthesis, that is, certain bacteria which love high temperature, they thrive in these environments. They can manufacture food using chemical energy that they derive from certain chemical reactions. Now, sometimes dissolved metals, they precipitate right in the water column, and then they settle down to the sea bottom. Are you able to see the cursor here? I'm moving the cursor.
Yes, yes.
Okay. So they precipitate in the water column and they fall down and settle on the seafloor. So we call them metalliferous sediments because they're rich in metals. Metals like copper, zinc, silver, and other things. That's a cross-section of the metalliferous sediments. You can see different layers very clearly here. Then we also have oil and natural gas deposits in the oceans. Now, basically, these oil and gas deposits form when organic matter on the seafloor is buried deep and it is subjected to high temperature and pressure conditions. So this organic matter is sort of cooked. Like in a pressure cooker, it is cooked and then we produce hydrocarbons. And hydrocarbons are the basic building blocks of petroleum and natural gas. So let's very quickly see how this happens in nature. Now we need a kitchen where organic matter is cooked in order to produce oil and gas, right? And then we need a container where oil and gas can accumulate and we can produce the oil and gas. So you need plumbing in order to connect the container with the kitchen. It's a nice cartoon which I found in the internet and I use it for common talks. And then we need correctly placed wells in order to produce oil and gas. So we need source rocks. We need migration of oil and gas from the source rock to the reservoir rocks. And here we have a trap that traps oil and gas, and there is a seal on top like muchula, which prevents the oil and gas from moving upwards any further. And then, of course, geologists, explore and engineers produce the oil. And these are some of the important Indian offshore oil and gas deposits. We find them in the Gulf of Cambay, the Bombay High, Kaveri Basin, Krishna Godavari, and Mahanadi basins. It's very interesting to see that on the east coast, wherever you have large rivers draining into the Bay of Bengal, and the sedimentation rate is very high, the organic matter is quickly buried, and therefore there are more chances of oil and gas forming there, and that's why we see all of these important deposits in the east coast. This is not karpur or camphor, but it's called gas hydrate. Now, these are ice-like solids. They are composed of water as molecular cages. All that is water. They form a molecular cage. And in the center, you have a gas that occupies in the middle. This gas can be anything. It can be carbon dioxide, but in our case, this is methane. And very interestingly, 1 cubic meter of gas hydrate, when we bring it up to the surface, sea surface, it expands to 164 cubic meters because it expands so much. And this is a very important resource that has been discovered in the more recent times, but there are challenges to exploring and exploiting these resources. Then you have such colorful minerals from the beach sands. We call them placer minerals. And they contain gold, silver, platinum, thorium, tin, iron, zirconium, rare earth elements, and whatnot. Now we find these on the beaches of Kerala, Tamil Nadu, Odisha, and a few other places, Maharashtra as well. And seawater itself is a great resource because it provides us with common salt, several chemicals, and drugs. Plus, in certain areas, water is scarce. Desalination is done in order to obtain potable water, fresh water. Any food resources from the oceans? Yes, plenty of them. We have finfish, shellfish, shrimps, lobsters, squid, cuttlefish, prawns, and You name it, you have it in the oceans. And India ranks number 10 in global fish production. In fact, we use acoustic surveys like that. We saw what it does, right? In order to locate dense populations of fish. And can we tap energy from the oceans? Yes, we can. They provide non-conventional energy resources. These are renewable and non-polluting. And such, ocean energy resources, the so-called non-conventional energy resources, have gained a lot of importance in the present times because of the greenhouse effect and the global warming and the talk about carbon footprint, etc., etc. So first we have the ocean thermal energy conversion, OTEC, OTEC. So we use the cold sea bottom water and the warm surface water to harness energy. Like how the refrigerator works. In a similar way, we use this. I won't go into the details, but if somebody is interested, we can discuss it later. Then we have the wave energy. When wind blows across the ocean surface, it produces waves. Like how, when you do oof, with a cup of coffee, you produce waves. And when you blow it very hard, it spills. So this is what happens in nature. So there is energy in the waves, and we try to tap this wave energy. So you place a turbine with a structure like this. When the wave goes up and down, you produce energy. It's like, imagine that there is a turbine, small turbine put in your throat somewhere here, and when you breathe in and breathe out, the turbine rotates and you can produce energy. Very similar to that, but I don't advise you to do this. Then, life in the oceans. You may be knowing that life originated in the oceans, and oceans have supported life in a variety of forms, microscopic algae to blue whales and thousands of species in between, millions. In fact, oceans contain 20% of all species of life present on our planet. But we are losing many of those species very fast. And those are coral reefs. These are solid limestone structures created on the seafloor by dead biological communities. And they offer, as you can see, a varied and colorful, fascinating ecosystem. These are also under threat because of climate change. Now we find mud, on the seafloor. What is it made up of? It contains clays and sands brought by rivers, shells and organic matter of dead animals, dead organisms, chemical compounds precipitated from seawater, and particles of dust that come from outer space. It's estimated that about 3.8 million tons of such cosmic dust comes onto the Earth's surface every year. Now, can we estimate or can we understand how the climate was in the past? Yes, in fact, some marine scientists do this. At Mangalore University, my research group concentrated on this, on studying the past climate. So that's a sediment core from the oceans, for example. And we use natural environmental records like marine sediments to infer how the climate was in the past. So we study not only the past climatic conditions, but all the underlying climate processes, what produce these changes. We also use ice cores, microscopic shells, corals, pollen, and spores to understand past climate. Are there any man-made or human-made structures on the seabed? Yes, there are plenty of them. In fact, marine archaeologists study the underwater cultural heritage. You may have heard of Dr. S.R. Rao, who was a marine archaeologist. He worked with the National Institute of Oceanography and investigated the structures that are found in Dwarka and other places. So what happened was ancient port towns got submerged as sea level rose about 11,000 years ago. So as the sea level rose, the port towns got submerged. Examples are Dwarka, Bet Dwarka, Somnath, and Pompuhar. Pompuhar is off Tamil Nadu coast. So all these are rich cultural heritages, cultural heritage. Now, what's the impact of human activities on the oceans? You know, wherever we go, we leave a trail of damage. And we have done this with the case of oceans as well. You know, as I mentioned, the oceans have become a blue-lidded global dustbin. We dump everything, all sorts of things. You know, coastal regions have attracted a lot of population because there are ports, harbors, and natural resources are shipped, and finished products are shipped out and all that from coastal regions. So there's a huge population living in coastal areas, which has contributed to excessive pollution of the ocean environment. Toxic metals like cadmium, copper, lead, mercury, nickel, they're released into the oceans. Also, these harbor activities relating to fishery, shipping, oil, land runoff, they also contribute to the pollution of the marine environment. Now, does the benevolent ocean get furious? At times, you know, the oceans also get angry. I gave this example earlier, right? When you blow the coffee very hard, it spills. And this is exactly what happens in monsoon season. We have coastal erosion. So during the monsoon, we have strong winds and they produce huge waves. So these huge waves contain a lot of energy. When they come and hit the coastal area, they destroy properties, their lives are lost, and beaches are eroded, as you can see here. This is very common along Mangalore and several other coastal tracts. And governments spend money every year on building seawalls, spending crores of rupees, but this is all a big waste of money. These are only temporary but not permanent solutions. My colleague, Professor Japa, has done extensive studies on this, and he also feels it's a waste of money. You know, tsunamis are the biggest waves ever filmed. What are tsunamis? They are huge, rapidly moving ocean waves, and they are triggered by disturbances of the seafloor. What are these disturbances? They are caused by earthquakes, submarine landslides, and submarine volcanic eruptions. So these tsunamis speed is about 600 miles per hour. It's very similar to what speed an aircraft moves. It's very similar to that. And the height is about 10 to 60 feet. So imagine a huge body of water, 60 feet high, coming and hitting like an aeroplane. You can imagine the amount of destruction that can take place. So usually when there is a tsunami, the sea level goes down and then rapidly comes up and spreads. So that is the indication of a tsunami. In case if you're on a beach and you notice this, please remember there is a tsunami, and what will you do? You will not only run away from the coast, but you will occupy higher positions. I'm told that Professor C.N.R. Rao was there in Sri Lanka when the 2004 tsunami happened. So go to higher elevations. I'd like you to notice here, you know, here it's very, the wavelength is long, the height is very small. But as it comes to the coastal region, the wavelength decreases and the height increases. So it becomes up to 60 feet high and then hits the coast. How important is Antarctica? Now, Antarctica is important because it provides vital insights into the tectonic history of the Earth, how the plates are moved. For example, how India has moved from Antarctica to its present-day position. So all that story Antarctica can tell us. Also, insights into certain processes like global warming, sea level rise, ozone depletion, etc., etc. Once again, India has been an active player in Antarctica. We have a solid program on Antarctic research. We have established Maitri and Bharati, 2 research stations in Antarctica. So this is an appeal. Oceans are important to us, as we have seen, and marine resources and the marine environment need to be protected from human influences. Our own KAAS member, Mr. Anand, has been giving talks on space exploration. So I would say that we have spent a lot of money on space exploration. We have conquered the outer space, but we have not yet fully understood the oceans, which are our inner space. There's still a lot of things to be understood about the oceans, and there's a need to preserve the marine environment. So in order to promote this idea, I invited school students to Samudra Ratnakar, the ship that I was mentioning to you, costing 650 crore rupees, so that they'll get enthused and take up careers in ocean sciences. So with that, I would like to thank you, ladies and gentlemen, for your time and attention. If you have any questions, I'll be pleased to answer them.
Thank you, Professor Shankar, for a very informative talk. You have talked about so many very interesting topics. Now, please answer a few questions if there are any. Now the floor is open for questions. Anybody who would like to ask any questions, you can raise your hand and then ask a question one by one. Okay, ಅವರು ಪ್ರಿಪೇರ್ ಆಗ್ತಾ ಇದ್ದಾರೆ. ನಾನು ಒಂದ್ 2-3 ಪ್ರಶ್ನೆಗಳು ಕೇಳ್ತೀನಿ. ಒಂದು ಐಡಿಯಾ ಅಬೌಟ್ ದ ಫಾರ್ಮೇಶನ್ ಆಫ್ ದ ಓಷನ್ಸ್, ಹೇಗೆ ಫಾರ್ಮ್ ಆಯ್ತು ಅಂತ. ಫಾರ್ಮೇಶನ್ ಓಷನ್ಸ್ ಬಗ್ಗೆ ಏನು ಹೇಳ್ತೀರಾ? Formation formed.
I mentioned it in my talk already.
Water ಎಲ್ಲಿಂದ ಬಂತು? Outside space. Water formation of the oceans. How the
ocean water.
Ocean water.
See, part of it was there in the gaseous form. See, when the earth formed, it was not a solid. It was a planetesimal theory anta heltare. Small blocks got collided and they formed the earth. Initially it was all gaseous. A lot of water vapor was there, and that condensed. Plus there is also water from other outer source. So when the temperature came down, the water vapor became water, and those formed the oceans.
Salinity, the oceanal salinity, what is the responsible for that saltiness of the oceans?
Yeah. See, what happens is, when rocks are weathered, they undergo chemical weathering. So minerals are transformed from one to another. And in the process, certain anions and cations are released during the chemical weathering. These cations and anions come in solution, they go into the river water, and the rivers ultimately reach the oceans. All right. So in the ocean basin, all these salts are accumulating, anions, cations. But what evaporates is only water, right? So these salts get accumulated in the oceans, so it becomes saline. That's the reason for salinity. But you may also ask Professor Kagli, in that case, the ocean water should go on becoming saltier and saltier every year, right? It doesn't happen like that, because the earth has a certain regulatory mechanism. For example, salts are inputted by rivers, anions and cations, but they're also removed, because marine animals, marine life takes out certain ions, and there is also chemical precipitation of various chemicals. So there is a sort of a balance, so that the salinity remains constant at 35 parts per 1,000, plus minus a few units.
ಇನ್ನೊಂದು ಏನು ಹೇಳಿದ್ರೆ 11,000 ವರ್ಷದ ಹಿಂದೆ 11,000 years ago,
yes,
rise in the sea level. What could be the reason for that? What was the reason? Some global warming such thing was there at that time. 11,000 years ago, you said there was a big rise in the sea level.
There are two reasons why sea level rises. One is the natural variability. Second is human influence. Natural variability andre, the earth goes around the sun, right? It's elliptical. Second thing is the earth rotates on its axis and this axis is tilted, right? So there are changes in the earth's rotation on its axis and its revolution around the sun. So as a result, how much of solar radiation reaches the earth's surface changes. Therefore, there is seasonality in our climate, and climate changes every 23,000 years, 41,000 years, and 100,000 years. These are referred to as EOP, eccentricity, obliquity, and precession. In short, they are called the Milankovitch cycles. This is all natural. When humans were not there, then also this has happened. But after human beings or Hanuman beings came into existence on planet Earth, we've all done monkey-like things. Koti kelsa madidevi. So we have produced a lot of changes in the Earth's climate.
Additional contributions we have made.
Yes. Anthropogenic activities have added carbon dioxide to the atmosphere. So there is greenhouse effect, global warming, climate change. So we have two things, right? Erdu serkondo we have the sea level rise.
Life originated in the oceans ಅಂತ ಹೇಳಿದ್ರೆ, what is the
one second. Can I add one more thing to this?
Please.
11,000 years ago, whatever sea level rose, that's only one small part of the history. Like that, in the past few million years, the sea level went up and down several times. Yeah, go ahead with your next question.
Next question. Life originated in the oceans ಅಂತ ಹೇಳಿದ್ರೆ, what is the proof for that? Can you justify your statement?
Well, there are two hypotheses. One is life forming in the oceans when you have amino acids forming because of lightning and certain triggering phenomena. Life has evolved anta ಹೇಳ್ತಾರೆ. ಎರಡನೇ hypothesis panspermia.
Comets in the ಬಂದಿದ್ದು.
That is life came from outer space and it evolved on the planet here anta ಹೇಳ್ತಾರೆ.
Okay, Professor Mallesh, would you like to ask question?
Sir, ಇದು temperature 380 degrees Celsius ಅಂತ ಹೇಳಿದ್ರಲ್ಲ sir, at what depth temperature is about 380 degrees Celsius?
This is around 2,500, 3,000 meters below the sea surface. My favorite question in the classroom would have been, illi kelidilla prashne because you're all physics people. My favorite question will be, ಅಲ್ಲಿ 380 degree centigrade ನಲ್ಲಿ ನೀರಾಗಿ ಉಳಿಯಕ್ಕೆ ಸಾಧ್ಯನಾ? Can it occur as water? But as physics people, you jolly well know why it is not converted into steam.
Pressure is high pressure is there.
Yes, exactly. Hydrostatic pressure.
Professor Mallesh would like to ask question. Okay, there Mallesh avara.
Sir, ನಮಸ್ತೆ.
ನಮಸ್ಕಾರ.
ತಮ್ಮ ಒಳ್ಳೆ ಉಪನ್ಯಾಸದ ಬಗ್ಗೆ ಅಭಿನಂದನೆಗಳು. ನನ್ನ ಪ್ರಶ್ನೆ, ಒಟ್ಟಾರೆ ನೀರಿನ ಕಂಟೆಂಟ್ ಅನ್ನೋದು ಒಂದು ರೀತಿ ಅಟ್ಲೀಸ್ಟ್ ಒಂದು ಆವರೇಜ್ ಇರ್ಲಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿದೆಯಾ ಅಥವಾ ಅದು ಚೇಂಜ್ ಆಗ್ತಾ ಇದೆಯಾ? ಒಟ್ಟು ನೀರಿನ ಕಂಟೆಂಟ್
ಸೇಮ್. ನೀರು ಆವಿ ಆಗಿರ್ಬೋದು, ಐಸ್ ಆಗಿರ್ಬೋದು, ಮಂಜುಗಡ್ಡೆ ಆಗಿರ್ಬೋದು, ಎಲ್ಲ ಸೇರ್ಕೊಂಡು ಹೆಚ್ಚು ಕಡಿಮೆ ಅಷ್ಟೇ ಇರುತ್ತೆ, ಎಲ್ಲೂ ಹೋಗಿರೋದಿಲ್ಲ. ಭೂಮಿಯ ಮೇಲೆ, ಮೇಲ್ಮೈ ಮೇಲೆ ಮತ್ತೆ ಒಳಗಡೆ ಎಲ್ಲ ಸೇರ್ಕೊಂಡು ಆಲ್ ಪುಟ್ ಟುಗೆದರ್ ಇಟ್ಸ್ ದ ಸೇಮ್.
ಅಲ್ಲ, ಮತ್ತೆ ನೀರನ್ನ ನಾವು ಯಾವ್ದೋ ಬೇರೆ ರಿಯಾಕ್ಷನ್ಸ್ ಇಂದ ನೀರು ಹೆಚ್ಚಾಗ್ತಾ ಇಲ್ವೇ ಅಥವಾ ನೀರನ್ನು ಕಳ್ಕೊಳ್ಳೋ ಸಾಧ್ಯತೆಗಳಿಲ್ವೇ? ಎಲ್ಲ ಒಂದು ಆ ರೀತಿ ನಾವು
ಅಂದ್ರೆ ನಮ್ಮ ಮನೆಯಿಂದ ಕಳ್ಕೋಬಹುದು, ನಮ್ಮ ದೇಶದಿಂದ ಕಳ್ಕೋಬಹುದು. ಭೂಮಿ ಆಸ್ ಅ ಹೋಲ್ ತಗೊಂಡ್ರೆ ಭೂಮಿಯಲ್ಲೇ ಇರುತ್ತೆ, ಸಮುದ್ರದಲ್ಲಿರುತ್ತೆ, ಇಲ್ಲ ಮಣ್ಣಿನಲ್ಲಿರುತ್ತೆ, ರಾಕ್ಸ್ ಒಳಗಡೆ ಇರುತ್ತೆ, ಗಾಳಿಯಲ್ಲಿರುತ್ತೆ, ವಾಯುಮಂಡಲದಲ್ಲಿರುತ್ತೆ, ಮತ್ತೆ ಸಸ್ಯ ಪ್ರಾಣಿಗಳಲ್ಲಿರ್ತವೆ, ನಮ್ಮ ದೇಹದಲ್ಲಿ ಇದೆ. 66% ಬರೀ ನೀರೇ ನಮ್ಮ ದೇಹದಲ್ಲಿರೋದು. ಸೊ ಹಾಗೆ ಬೇರೆ ಬೇರೆ ರೂಪದಲ್ಲಿರುತ್ತೆ.
So whatever water was there in the beginning, we are roughly the same amount is there at present also.
If you take the entire earth, yes, about the same.
Thank you, sir.
Welcome.
Is there any difference in the minerals content under seabed and under the normal our land land floor? ಯಾಕಂದ್ರೆ ಅಲ್ಲಿ ಪ್ರೆಷರ್ ಜಾಸ್ತಿ ಇರುತ್ತಲ್ಲ, ಅದರ sea pressure ಅಲ್ಲಿ. So any particular type of minerals are more likely to be present there? The idea is what type of minerals are more likely to be found under seabed?
When you say minerals, are you referring to economically important minerals?
Minerals like iron, copper, gold.
Okay. You asked me a very interesting question. See, ocean exploration has given us some very good insights. What is that insight? Now we know that mineral deposits like what we find in Kolar, gold deposits, Chitradurga, copper deposits, Rajasthan, we get all these deposits. So what it says is, we know now that all these deposits formed under the oceans in much the same way as how they are forming today. I showed some slides, you remember? Hydrothermal activity, sea floor nalli water going down and coming up as hot water springs. So all these deposits formed in the same way. So if you go to Chitradurga, my native place, there are enough lines of evidence to say that it was once upon a time oceans. So the copper deposit there formed under the oceans, but today it has come up above the sea level. Okay.
Sir, ಮತ್ತೆ ಇನ್ನೊಂದು ರಿಗಾರ್ಡಿಂಗ್ ಹೀಟ್, ಹೈ ಹೀಟ್ ಫ್ಲೋ ಅಂತ ಹೇಳಿದ್ರಲ್ಲ ಸರ್, ಅದು ಹೇಗೆ, ಹೌ ಇಟ್ ಈಸ್ ಪಾಸಿಬಲ್ ದೇರ್ ದಿ ಹೈ heat flow?
See, what happens is, in nature, there are radioactive minerals. Okay. And because of radioactivity, there is radiogenic heat. And that heat is responsible for all the convective activity that I showed in the diagram. High heat flow is all because of that. Do you want me to show the diagram?
Yes, sir. I didn't look at it properly.
We will go to that.
ನನ್ನ ಡೌಟ್ ಯಾತಕ್ಕೆ ಅಂದ್ರೆ, ಫ್ಲೋ ಆಗ್ತಾ ಇದ್ರೆ ಆವಾಗ ಸ್ವಲ್ಪ ಹೀಟ್ ಜನರೇಷನ್ ಆಗ್ಬೋದು. ಆಲ್ಮೋಸ್ಟ್ ಸ್ಟಾಗ್ನೆಂಟ್ ಅಲ್ವಾ ಸರ್ ಅಟ್ ದಿ ಬಾಟಮ್ ಆಫ್ ದಿ ಸಿ? ಬಟ್
ಇಲ್ಲ, ನಾವಾಗಲೇ ಹೇಳಿದ್ನಲ್ಲ, ವಾಟರ್ ಇಸ್ ನಾಟ್ ಸ್ಟಾಗ್ನೆಂಟ್, ಇಟ್ ಈಸ್ ಕ್ರೇಜಿ, keeps moving from one place to another. That's why you have ocean currents. Ocean currents ಇಲ್ಲಿದೆ ನೋಡಿ ಸರ್, ಕಾಣ್ತಾ ಇದು? Can you see this?
ಕಾಣಿಸ್ತಾ ಇದೆ ಸರ್, ಕಾಣಿಸ್ತಾ ಇದೆ.
So water moves in all directions. ಅಲ್ಲಿ ಇಲ್ಲಿ ಬೇರೆ ಬೇರೆ ಡೆಪ್ತ್ ನಲ್ಲಿ ಬೇರೆ ಬೇರೆ ಡೈರೆಕ್ಷನ್, ಬೇರೆ ಬೇರೆ ಸ್ಪೀಡ್ ನಲ್ಲಿ ಹೋಗ್ತಾ ಇರುತ್ತೆ. ಸೊ ಹೀಟ್ ಏನ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗುತ್ತೆ ಒಂದು ಕಡೆ, ಇಟ್ ಇಸ್ ಕಂಟಿನ್ಯೂಸ್ಲಿ ರೀಡಿಸ್ಟ್ರಿಬ್ಯೂಟೆಡ್ ಥ್ರೂಔಟ್ ದ ಓಷನ್ಸ್. ಈಗ ಎಕ್ವೆಟೋರಿಯಲ್ ರೀಜನ್ ಅಲ್ಲಿ ಹೀಟ್ ಜಾಸ್ತಿ ಬರುತ್ತೆ, ಹೌದಾ?
ಹೌದು ಸರ್, ಹೌದು.
ಸೊ ಅದರಿಂದ ಮತ್ತೆ ಸರ್ಫೇಸ್ ಕರೆಂಟ್ಸ್ ಫಾರ್ಮ್ ಆಗಿ, ಇದ್ರಲ್ಲಿ ನೋಡಿ, ಸರ್ಫೇಸ್ ಕರೆಂಟ್ಸ್ ಅಲ್ಲಿ ಹೋಗುತ್ತೆ ಮೇಲೆ, ಕೋಲ್ಡ್ ರೀಜನ್ಗೆ ಹೋದಾಗ ಇಟ್ ಕೂಲ್ಸ್ ಡೌನ್, ಸಿಂಕ್ಸ್ ಟು ದ ಸಿ ಬಾಟಮ್, ಬಾಟಮ್ ಕರೆಂಟ್ ಆಗಿ ಬರುತ್ತೆ ಇಲ್ಲಿಗೆ. ಮತ್ತೆ ಇಲ್ಲಿ ನೋಡಿ, ಇದು ರೆಡ್ ಇರೋದು ಸರ್ಫೇಸ್, ಹಾಟ್ ವಾಟರ್, ವಾರ್ಮ್ ವಾಟರ್ ಗೋಸ್ ದೇರ್ and sinks to the sea bottom, comes as bottom water. So it's continuously moving.
Okay, thank you sir.
ಈಗ ನಮ್ಮ ಹ್ಯೂಮನ್ ಬಾಡಿಯಲ್ಲಿ, ಈಗ ನಾವೆಲ್ಲರೂ ಕೈ ಐಸ್ ನಲ್ಲಿ ಇಟ್ಟರೆ ತಣ್ಣಗಾಗತ್ತೆ, ಬಟ್ ಅದು ಕಂಟಿನ್ಯೂಸ್ಲಿ ಬ್ಲಡ್ ಸರ್ಕ್ಯುಲೇಷನ್ ಆಗೋದ್ರಿಂದ ಫ್ರೀಸ್ ಆಗೋದಿಲ್ಲ ಕೈ, ಹೌದಾ? ಸ್ವಲ್ಪ ಎಫೆಕ್ಟ್ ಆಗುತ್ತೆ, ಬಟ್ ಫ್ರೀಸ್ ಆಗೋದಿಲ್ಲ. ಹಾಗೆ
One more question. Sangur,
Yes,
Sangur,
please.
please ask.
Sir, I am Dr. Sangur Mat.
ನಮಸ್ಕಾರ ಸರ್.
ನಮ್ಮ ಪ್ರೊಫೆಸರ್ ಶಂಕರ್ ಸರ್ ನಮ್ಮ ಗುರುಗಳು ತುಂಬಾ ಚೆನ್ನಾಗಿ
ಎಲ್ಲರೂ ಗೋರ್ಗೊಳ್ರಿ ನಮಗೆ.
ಪ್ರಶ್ನೆ ಕೇಳಿ.
ನಮ್ಮ ಅವರ ಒಂದು ತಪಸ್ಸಿನಿಂದಾಗಿ ಎಲ್ಲ ಚೆನ್ನಾಗಿ ಪ್ರೆಸೆಂಟೇಶನ್ ಮಾಡಿದ್ರು.
ಗುರುಗಳಿಗೆ ಪ್ರಶ್ನೆ ಕೇಳಬೇಕು, ಅವಾಗ ಖುಷಿ ಆಗುತ್ತೆ ಗುರುಗಳಿಗೆ.
ಕ್ವಶನ್ ಕೇಳ್ತಾ ಇದ್ದೀನಿ ಸರ್, ಈಗ ಬರ್ತೀವಿ. ಬಂದ್ಬಿಟ್ಟು ತುಂಬಾ ಚೆನ್ನಾಗಿ ಎಲ್ಲ ಪಾಯಿಂಟ್ಸ್ ಗಳನ್ನ ಕವರ್ ಮಾಡಿದ್ರು. ಆದ್ರೆ ಈಗ ಸದ್ಯ ಸಮುದ್ರದಲ್ಲಿ ಬೇರೆ ಬೇರೆ ಡಿಪಾರ್ಟ್ಮೆಂಟ್ಗಳು ಸಾಕಷ್ಟು ಎಕ್ಸ್ಪ್ಲೋರೇಷನ್ ಮಾಡ್ತಾ ಇದಾರೆ. ಡಿಪಾರ್ಟ್ಮೆಂಟ್ ಆಫ್ ಓಷನ್ ಡೆವಲಪ್ಮೆಂಟ್, ಮಿನಿಸ್ಟ್ರಿ ಆಫ್ ಅರ್ತ್ ಸೈನ್ಸ್, ಮೆರೈನ್ ಜಿಯಾಲಜಿ ವಿಂಗ್, ಜಿಯಾಲಜಿಕಲ್ ಸರ್ವೆ ಆಫ್ ಇಂಡಿಯಾ, ನ್ಯಾಷನಲ್ ಆಫ್ ಓಷನೋಗ್ರಫಿ, ಇಂಡಿಯನ್ ರೇರ್ ಅರ್ತ್ಸ್ ಲಿಮಿಟೆಡ್ ಮತ್ತು ಯೂನಿವರ್ಸಿಟೀಸ್ ಅಂಡ್ IITs ಮಾಡ್ತಾ ಇದ್ದಾರೆ. ಈಗ ಹೊಸದು ಏನಿದೆ ಅಂದ್ರೆ ಇನ್ನೂ ನಮಗೆ ಬೇಕಾಗ್ತಿರೋದು ನವಡೇಸ್ ಅರ್ಲಿಯರ್ ಓನ್ಲಿ ಯೂಸ್ಡ್ ಟು ಸಿ ದಿ ಓನ್ಲಿ ಫ್ಯೂ ಮಿನರಲ್ಸ್. ನೌ ಆಲ್ಮೋಸ್ಟ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಫಾರ್ ದಿ ಎಂಟೈರ್ ಪಿರಾಡಿಕ್ ಟೇಬಲ್. ಅದರಲ್ಲೂ ಮೇನ್ಲಿ ಕ್ರಿಟಿಕಲ್ ಮಿನರಲ್ಸ್ ಬಗ್ಗೆ ಸಾಕಷ್ಟು ಸ್ಟಡಿಗಳು ನಡೀತಾ ಇದೆ. ಕ್ರಿಟಿಕಲ್ ಮಿನರಲ್ಸ್ ಬಗ್ಗೆ ಸಾಕಷ್ಟು ಸ್ಟಡಿ ನಡೀತಾ ಇದೆ. ನನಗೆ ಇವತ್ತಿನ ಒಂದು ಪ್ರೆಸೆಂಟೇಶನ್ ನೋಡಿದ್ರೆ ನಾನು ಸಾಗರ ಕನ್ಯಾ ಶಿಪ್ ನಲ್ಲಿ ಅಡ್ಡಾಡೋದು ನೆನಪು ಬಂತು. ತುಂಬಾ ಚೆನ್ನಾಗಿದೆ. ಈಗ ಕ್ರಿಟಿಕಲ್ ಮಿನರಲ್ಸ್ ಬಗ್ಗೆ ಸಹಿತ ಸಾಕಷ್ಟು ಒಂದು ಎಕ್ಸ್ಪ್ಲೋರೇಷನ್, ಇವ್ಯಾಲ್ಯೂಯೇಷನ್ ನಡೀತಾ ಇದೆ. ವಾಟ್ ಓಕೆ. ಥ್ಯಾಂಕ್ ಯು ವೆರಿ ಮಚ್ ಸರ್. ಇಟ್ ವಾಸ್ ಎನ್ ಎಕ್ಸಲೆಂಟ್ ಪ್ರೆಸೆಂಟೇಶನ್. ಥ್ಯಾಂಕ್ ಯು.
ಥ್ಯಾಂಕ್ ಯು. ಥ್ಯಾಂಕ್ ಯು.
ಇನ್ನೊಂದು, ನೀವು ಟೆಕ್ಟಾನಿಕ್ ಪ್ಲೇಟ್ಸ್ ಬಗ್ಗೆ ಹೇಳಿದ್ರೆ, ಅದೇ ಟೆಕ್ಟಾನಿಕ್ ಪ್ಲೇಟ್ಸ್, ದೇ ಆರ್ ಫಿಕ್ಸ್ಡ್ ಪ್ಲೇಟ್ಸ್, ಆರ್ ದ ಬೌಂಡರೀಸ್ ಗೋ ಆನ್ ವೇರಿಂಗ್, ಆರ್ ದೇರ್ ಬೌಂಡರೀಸ್ ಆರ್ ಫಿಕ್ಸ್ಡ್, ದಿಸ್ ಟೆಕ್ಟಾನಿಕ್ ಪ್ಲೇಟ್ಸ್?
ಇವತ್ತಿನ ಪ್ರಕಾರ those are the boundaries, but the boundaries themselves keep changing.
That's what I want to go.
Because the plates are moving, boundaries are also moving. If you take a long time into account, millions of years, it's a very different scenario. I wish I could show a diagram which shows how the plates are moved, how the plate boundaries themselves are moved.
ಇನ್ನೊಂದು ಥಿಯರಿ ಕೇಳಿದೀವಿ, ದಟ್ ಇಂಡಿಯಾ ಅಂಡ್ ಅದರ್ ಪಾರ್ಟ್ಸ್ ವರ್ ಜಾಯಿಂಡ್ ವಿತ್ ಆಫ್ರಿಕಾ ಅಂಡ್ ಆಸ್ಟ್ರೇಲಿಯಾ ಅಂತ ಹೇಳಿ ದೊಡ್ಡ ಕಾಂಟಿನೆಂಟ್ ಇತ್ತು ಅಂತ. Then they drifted away and they formed different continents. Can you tell us about that? How why they drifted away?
Yes. So initially, all the southern continents like India, Australia, Africa, South America, they were all joined together as one single landmass.
Land ಅಂತ ಹೇಳ್ತಾರೆ. Proof for that? What is the proof? What is the proof for that?
What is the proof for that? Yes. That can form another talk, but very briefly, we have evidence from the type of rocks, the type of mineral deposits, the type of fossils that we find in all of these southern continents, India, Australia, South America, Africa, all these commonalities are there.
Okay.
So that is the main evidence to say that they were all together, and they were at in the Antarctic region. Say, for example, Odisha Bihar regionally, we have rocks that tell us that it was glacial climate. Dot boulders sigutte, and they are very characteristic of glacial climate. Iga namige we know that there is no glaciers in Odisha, right? Athara there are several lines of evidence to say that India was once upon a time in the Antarctic region, and it has traveled for thousands of kilometers over millions of years time scale.
ಸರ್, ಇನ್ನೊಂದು ಸಮುದ್ರ ಮಂಥನ ಅನ್ನೋದೇನೋ ಒಂದು ಪಿಕ್ಚರ್ ತೋರಿಸ್ತೀರಿ ಬಿಗಿನಿಂಗ್ ಅಲ್ಲಿ ಸರ್, ಅದು ಎಲ್ಲಿ ಇರೋದು? ಪಿಕ್ಚರ್ ತೆಗೆದಿದ್ದು
ಪುರಾಣ,
ಅದು ಏನಾದ್ರಿ ಕಾಗ್ಲಿವ್ರೆ
ಪುರಾಣ ಅಂತ ಹೇಳಿದ.
ಅಲ್ಲ, ಪುರಾಣ ಫೋಟೋ ತೆಗ್ದಿರೋದು ಸುವರ್ಣ ಭೂಮಿ ಏರ್ಪೋರ್ಟ್, ಬ್ಯಾಂಕಾಕ್ ಏರ್ಪೋರ್ಟ್. ಬ್ಯಾಂಕಾಕ್ ಏರ್ಪೋರ್ಟ್ ನಲ್ಲಿ ತುಂಬಾ ಚೆನ್ನಾಗಿತ್ತು. ಫೋಟೋ ತಕೊಂಡು ಇದಕ್ಕೆ ಯೂಸ್ ಮಾಡಿದೆ.
ತುಂಬಾ ಚೆನ್ನಾಗಿದೆ ಫೋಟೋ
ಅಲ್ವಾ? ತುಂಬಾ ಚೆನ್ನಾಗಿದೆ. ಸಮುದ್ರ ಮಂಥನ.
ಮತ್ತೆ ಪ್ರಶ್ನೆ ಇದೆಯಾ
ಸರ್? ನಾನು ಇನ್ನೊಂದು ಪ್ರಶ್ನೆ ಕೇಳ್ಬೇಕಂತ
ಹೇಳಿ.
ನೀವು ಕಾಂಟಿನೆಂಟ್ ಡ್ರಿಫ್ಟಿಂಗ್ ಬಗ್ಗೆ ಹೇಳ್ತಾ ನನಗೆ ಅವುಗಳ ಬೌಂಡ್ರಿ ನೋಡಿದ್ರೇನೆ ಒಂದು ಜಿಗ್ಸಾ ಪಜಲ್ ತರ ಒಂಚೂರು ಅನ್ಸುತ್ತೆ. ಅದು ಒಂದು
ಸರ್, ಇದು ನೀವ್ ಹೇಳಿದ್ದು ತುಂಬಾ ಕರೆಕ್ಟ್. ನೀವ್ ಹೇಳಿದ್ದು
ಇನ್ನೊಂದು ಪ್ರಶ್ನೆ ಸರ್, ನೀವು
ಸರ್ ಒಂದ್ ನಿಮಿಷ
ನಾನೇ ಮರ್ತು ಬಿಟ್ಟಿದ್ದೆ ಪ್ರಶ್ನೆ.
ನೋಡಿ, ಈ ಕಾಂಟಿನೆಂಟಲ್ ಡ್ರಿಫ್ಟ್ ಬಗ್ಗೆ ಫಸ್ಟ್ ಹೆಂಗೆ ಹುಟ್ಟಿತು ಅಂದ್ರೆ ಮನಸ್ಸಿನಲ್ಲಿ ಅಲೆಕ್ಸಾಂಡರ್ ಡ್ಯೂಟಾಟ್ ಅಂತ ಒಬ್ಬ ಸೈಂಟಿಸ್ಟ್ ಇದ್ದ. ಅವ ಏನ್ ನೋಡ್ದ, ಫಸ್ಟ್ ಮ್ಯಾಪ್ ನೋಡಿದಾಗ ಈ ನೋಡಿ ಈ ಬೌಂಡ್ರಿ ಕಾಣುತ್ತಾ, ನಾರ್ತ್ ಅಮೆರಿಕಾ ಸೌತ್ ಅಮೆರಿಕದ ಬೌಂಡ್ರಿ ಮತ್ತೆ ಈ ಆಫ್ರಿಕಾ ಬೌಂಡ್ರಿ ಜೋಡಿಸ್ತ, ಬಹಳ ಚೆನ್ನಾಗಿ ಫಿಟ್ ಆಯ್ತು. ಆಮೇಲೆ ಅಲ್ಲಿಂದ ಶುರು ಆಯ್ತು ಯೋಚನೆ ಮಾಡೋದು. ಈಗಲೂ ಕೂಡ ನೋಡಿ ಎಷ್ಟು ನೀಟಾಗಿ ಫಿಟ್ ಆಗುತ್ತೆ ಅನ್ಸುತ್ತಲ್ಲ, ಲೈಕ್ ಎ ಜಿಗ್ಸಾ ಪಜಲ್. ಹೇಳಿ, ಮತ್ತೆ ನಿಮ್ ಪ್ರಶ್ನೆ ಏನಿದೆ ಹೇಳಿ.
ನನ್ನ ಪ್ರಶ್ನೆ, ಎಲ್ಲ ಒಂದ್ ಕಡೆ 380 ಡಿಗ್ರಿ ಅಷ್ಟು ಟೆಂಪರೇಚರ್ ಇದೆ ಅಂದ್ರಲ್ಲ, ಈ
ಎಲ್ಲ ಕಡೆ ಅಲ್ಲ ಸರ್.
ಸರಿ,
ಎಲ್ಲೆಲ್ಲಿ ಹಾಟ್ ಸ್ಪ್ರಿಂಗ್ ಬರುತ್ತೆ ಅಲ್ಲಿ ಮಾತ್ರ.
ಸರಿ. ಥರ್ಮೋ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಉಪಯೋಗಿಸಿ ವಿದ್ಯುತ್ ತಯಾರಿಸುವಂತ ಸಾಧ್ಯತೆಗಳು ಇದ್ದೇ ಇರ್ಬೇಕೇನೋ, ಅದ್ರ ಬಗ್ಗೆ ಏನಾದ್ರು ಮಾಡಿ.
ಖಂಡಿತ. ಜಿಯೋಥರ್ಮಲ್ ಎನರ್ಜಿ ಅಂತ ಹೇಳ್ತೀವಿ. ಜಿಯೋಥರ್ಮಲ್ ಎನರ್ಜಿ ಅಂತ ಈಗ ಭೂಮಿ ಮೇಲೂ ಕೂಡ ಹಿಮಾಲಯನ್ ರೀಜನ್ ಅಲ್ಲಿ ಹಾಟ್ ಸ್ಪ್ರಿಂಗ್ಸ್ ಇದಾವ್ರಿ. ಈಗ ಮೆಕ್ಸಿಕೋನಲ್ಲಿ ಮತ್ತೆ ಐಸ್ಲ್ಯಾಂಡ್ ನಲ್ಲಿ ಅಲ್ಲೆಲ್ಲ ದೇ ಆರ್ ಯೂಸಿಂಗ್ ಜಿಯೋಥರ್ಮಲ್ ಎನರ್ಜಿ ಫ್ರಮ್ ದ ಹಾಟ್ ವಾಟರ್ ದಟ್ ಕಮ್ಸ್ ಔಟ್, ಎನರ್ಜಿ ಫ್ರಮ್ ಡೀಪ್ ವಿದಿನ್ ದ ಅರ್ತ್. ಅಲ್ಲಿ ಹಾಟ್ ಇರ್ತವೆ ರಾಕ್ಸ್, ಸೊ ಯು ಕ್ಯಾನ್ ಸೆಂಡ್ ಕೋಲ್ಡ್ ವಾಟರ್ ಅಂಡ್ ಗೆಟ್ ಹಾಟ್ ವಾಟರ್ ಅಪ್ and can also produce steam and run the turbines to produce the electricity. ಮತ್ತೆ ಹಾಟ್ ಸ್ಪ್ರಿಂಗ್ಸ್ ಆನ್ ದ ಓಷನ್ ಫ್ಲೋರ್ ಹೇಳಿದ್ನಲ್ಲ, people are thinking that when ocean mining begins in the future, we can utilize this geothermal energy from hot springs and those areas for mining operations.
ಇನ್ನೊಂದು, ನಾವು ಓಷನ್ಸ್ ಅನ್ನ ಹೇಳುವಾಗ ಇಂಡಿಯನ್ ಓಷನ್, ಪೆಸಿಫಿಕ್ ಓಷನ್, ಅಟ್ಲಾಂಟಿಕ್ ಏನೆಲ್ಲ ಹೇಳ್ತಾ ಇರ್ತೀವಲ್ಲ, are there any clear boundaries for the oceans? Are they mix ಆಗ್ತಾ ಇದೀಗ? There are clear boundaries between oceans?
No, there are not really clear boundaries, and as I said, ocean waters are all mixing.
But still boundaries are there.
Boundaries, these are all human made boundaries. Like in the atmosphere, air is getting mixed up all around. Ocean water is again getting mixed up all around.
Okay. So ಮತ್ತೇನು ಪ್ರಶ್ನೆ ಇಲ್ಲ ಅಂತಂದ್ರೆ ಪ್ರೊಫೆಸರ್ ನಾಗರಾಜ್, ಜನರಲ್ ಸೆಕ್ರೆಟರಿ, ಐ ರಿಕ್ವೆಸ್ಟ್ ಹಿಮ್ ಟು ಪ್ರಪೋಸ್.
ಸರ್, ಪ್ರೊಫೆಸರ್ ಶಂಕರ್ ಅವರು ನೀವು ತುಂಬಾ ಚೆನ್ನಾಗಿ ಹೇಳಿದ್ದೀರಾ ಸ್ಟೋರಿ ಆಫ್ ಓಷನ್ ಬಗ್ಗೆ. ಜೊತೆಗೆ ನಾವು ಏನೇನು ಪ್ರಶ್ನೆಗಳ ಕೇಳಿದ್ವಿ ಆ ಪ್ರಶ್ನೆಗಳಿಗೆಲ್ಲ ಉತ್ತರನ ಸಾಕಷ್ಟು ಸ್ಪಷ್ಟವಾಗಿ ನೀಡಿದ್ದೀರಾ. KPI ಇಂದ ನಿಮ್ಗೆ ಧನ್ಯವಾದಗಳನ್ನ ತಲುಪಿಸೋದಕ್ಕೆ ಇಷ್ಟಪಡ್ತೀವಿ ಸರ್. ಜೊತೆಗೆ ನೀವು ಯಾವುದೋ ಒಂದು ಹೇಳಿದ್ರಿ, ಅದು ಇನ್ನೂ ಒಂದು ಪ್ರೊಫೆಸರ್ ಕಾಗ್ಲಿ ಅವ್ರು ಕೇಳಿದಾಗ ಇನ್ನೂ ಒಂದು ಟಾಕ್ ಅಂತ ಹೇಳಿದ್ರಿ. ಬಹುಶಃ ಇನ್ನೂ ಒಂದು ಟಾಕ್ ಕೊಡೋದಕ್ಕೆ ರೆಡಿಯಾಗಿ, ನಾವು ಕೇಳಿಸ್ಕೊಳ್ಳೋದಕ್ಕೆ ರೆಡಿಯಾಗಿ ಖಂಡಿತ ಇರ್ತೀವಿ. ಸೊ ಹಾಗಾಗಿ ನೀವು ಇನ್ನೂ ಒಂದ್ಸಾರಿ ನಮ್ಗೆ ಈ ಸಮುದ್ರದ ಬಗ್ಗೆನೆ ಹೇಳಿದ್ರೆ